We're going to continue where we left off yesterday, which is on page 2 of your notes for Chapter 7, Exponential Functions. Exponential functions, and page 2 you should have all filled out up until example 9, and then I asked you to do examples 10 and 11 in class. And I think I mentioned that I'll show you the solution on the video. So what I would do, there's a couple different ways to approach this one. One way you could approach this is to see this -3 exponent and just flip this fraction upside down right away and make the denominator move to the numerator and the entire numerator move to the denominator, and then change this to a +3. That's one way, and that's fine. But what I would do would be to make it a little bit easier, I would simplify what's inside parentheses first, and then with the resulting simplified fraction, then I would flip it and change the negative exponent to a positive. It just creates a little bit less writing on our part. So if we have 4/2, I usually take care of the numerical coefficients first. 4/2 reduces down to 2/1. And now I have a couple of factors with negative exponents. So this x to the -1 will move up to the numerator and be called x to the +1. And this z to the -1 will move down to the denominator and be called z to the +1. So I have two factors that are moving. So in the meantime, we have the 2 in the numerator. This is the x to the 4th that hasn't moved. Now I'm going to move this x to the -1 up to the top and call it x to the +1 to put my x's next to each other. Then I have a y² that didn't move, and then this z to the -1 moved to the denominator. In the denominator, this 2 canceled out, or you could have called it 1. This x to the -1 has moved. This y to the 7th hasn't done anything, so he stays downstairs as a y to the 7th, and then this z to the -1 moved downstairs and became z to the +1. Now this whole thing is taken to the -3 power. The next thing I would do is I would combine the x to the 4th times x to the 1st. This is the multiplication rule, and this becomes 2 times x to the 5th. Now we'll handle the y's. We have a y to the 2nd in the top and a y to the 7th in the bottom. So when this happens, we have the division rule, which means you're going to subtract exponents. You could call this 2 minus 7, and you would get a result of y to the -5th in the numerator, which has to be moved down to the denominator. Or the easier way is, because the bigger exponent is in the denominator, you're just going to subtract the 2 exponents and keep the result in the denominator, because the y to the 7th is bigger than the y to the 2nd. So this y has an exponent of 7 minus 2 y to the 5th, which is the same thing as y to the -5th up in the top. And then this z to the 1st just stays a z in the bottom. And I think we've taken care of everything inside parentheses, but we still have to raise it to the -3 power. So at this point in time, we can flip the fraction upside down and have a y to the 5th on the top, a z on the top, and a 2x to the 5th in the bottom, and change the -3 to a +3. And then what we would do is we would apply the 3 exponent to every factor, and there are 4 of them. There's 2 in the numerator and 2 in the denominator. So this y to the 5th raised to the 3rd power becomes y to the 15th, because it's a power of a power, and then the z is cubed. And on the bottom we have 2 raised up to the 3rd power. 2 to the 3rd is 8. And x to the 5th, we have another power of a power, so you multiply exponents. X to the 5th raised up to the 3rd, multiply exponents, and you get x to the 15th power. And that is one way of probably 5 or 6 different ways you can approach this problem to simplify it down. It can't get any simpler than that. Number 11. Again, I would simplify what's inside parentheses first and then flip it and change the negative exponent to a positive. So negative 5, negative over positive stays a negative, and 5 over 25 becomes 1 over 5. The a to the negative 2 is going to move down to the denominator, and the b to the negative 1 is going to move down to the denominator, but the c stays in the numerator because it doesn't have an exponent at all. So what we have is a negative 1 on top and a c, and in the bottom we have a 5, and we have an a to the positive 2 and a b to the positive 1. But this whole fraction has to be raised to the negative 2 power. So we're going to flip this upside down and change negative to positive. So this becomes 5a squared b on the top, and negative 1 is just negative 1 times c is just negative c to the second power. And now the last thing to do is to apply the 2 to every factor, to the 5, to the a squared, and to the b, and to the negative c. 5 squared is 25. A squared squared, multiply the exponents and you get a to the 4th. B gets squared. And on the bottom, negative c squared, negative c times negative c is positive c squared. Remember, if you take a negative factor up to an even exponent, the result is going to be positive. So here's the final result. It's positive. 25a to the 4th b squared over c squared. In the next section, we're going to be talking about multiplication, and 3 of these examples concern fractions. And if you look through each one of these fractions, you'll see that you don't have any plus or minus signs in there. In other words, all you have are factors. 4 times x cubed times y times x all over x times y squared times 12 times y. So these are all factors. So when you have two fractions multiplied by each other, the easiest thing to do is to reduce the fractions as much as possible first. Any factor in any denominator, or in any numerator, as long as they're factors and not terms, can reduce with any factor in any denominator. And what do I mean by that? What I'm going to do is I'm going to look at this. We have two fractions. We have a numerator, denominator, numerator, denominator. These are all factors. None of them are terms. And so what I'm going to do is I'm going to look to reduce a numerator and a denominator. The first thing I see is 4 in the numerator, 12 in the denominator. They can reduce down to 4 divided by 12 is 1/3. The next thing I can look at is I have an x way over here in this numerator and an x over here in this denominator. So I'm going to just cancel those out because x over x is just a 1. The next thing I'm going to look at is a y in this denominator and a y in this numerator. They can cancel out. Y over y is 1. Now I could have reduced these y's, I could have reduced these x's, but I'm just looking to do the easiest thing possible. So what I have left with is a 1 and an x cubed in the numerator, and a 3 and a y squared in the denominator. And there's really nothing else you can do to reduce that. So that's the simplified version. Now we're going to just write this all out. What we have left in the numerator, like we said, was an x to the 3rd. This is what's left. And in the denominator, we are left with the 3. We usually write the numerical coefficient first, and then y squared in the denominator. And that's simplified down as much as possible because we can't reduce an x and a y. They have different bases. So like I said, that's one of many, many different ways we can reduce, but I think that's probably the easiest way. In the second example, I see an 8 in the numerator and a 12 in this denominator, which could reduce if I wanted to, or if I wanted to reduce the 8 over 6, I could do it that way, or if I wanted to reduce the 3 over 6, or the 3 over 12. There are many, many different ways to approach this, and I'm not sure which one is the best. But let's just start with, I guess I'll do it this way, 8 over 12. Well, there's a 4 in 8. 4 goes into 8 twice. 4 goes into 12 3 times. So 8 over 12 reduces down to 2/3. 3 over 6 reduces down to a half. And then I have a 2 in the numerator and a 2 in the denominator, so this 2 cancels out with this 2. And numerically, all we're left with is a 1 in the numerator and a 3 in the denominator. The next thing we can do is, like I said, there's many ways to approach this. One way is we can move this y to the negative fourth down, and it can become y to the positive fourth in the denominator. So anytime I move something with a negative exponent, I'll just lightly cross it out. And then this y to the negative 3 in the denominator, he can move up to the numerator and become y to the positive 3. One of many ways to do this problem. So what do I have left here? I've crossed out the 2. I think I'm only left with a y to the third times 1 in the numerator. So I'm just going to write this out temporarily. We've got a y to the third in the numerator. In the denominator, we're left with a 3 over here. The 12 got crossed out. The y to the negative third moved up. The 2 crossed out. Oh, this y is left. So we'll put this y here. And then this y to the negative fourth moved down, so I'll move it here. And now what we have is y cubed over 3 times y to the fourth is y to the fifth. And then the last thing we can do is, because we have a y in the numerator and a y in the denominator, we can use our quotient rule to subtract those exponents. But because we have a bigger exponent in the denominator, 5 is bigger than 3, we're going to subtract 5 minus 3 and keep our y in the denominator. So if we cancel out this y to the third, we're left with a 1 on the top, a 3 on the bottom, and 5 minus 3 leaves us with y squared in the denominator. So this is our final answer, one of many ways to get this final answer, 1 over 3y squared. Our next example. Again, I'm looking and seeing that I don't have any terms. There are no pluses or minuses. This is all multiplication across the top and across the bottom. So what I have here is I have a 20 in the top and a 2 in the bottom, and 20 divided by 2 is 10. So there's my numerical coefficient. In the denominator, I have an x to the third times x to the first. So I think one way of many ways doing this, I can call this x to the fourth, because in the denominator, we're just multiplying across. 3x to the third times x to the first is x to the fourth. In the numerator, we have a y to the 10th and a y to the 6th, and because they're both in the numerator, they're multiplication, and we can just add those exponents. So 10 plus negative 6 is equal to 4. So y to the 10th times y to the negative 6 leaves us with y to the positive 4 in the numerator. And then the last thing we can do is we have x to the 14th in the numerator, x to the 4th in the denominator. And this is a quotient rule. Numerator over denominator says we're going to subtract those exponents. X to the 14th all over x to the 4th is x to the 10th. So it looks like we've canceled everything out of the denominator. And when that happens, we don't have a fraction anymore. So what we're left with in the numerator is a 10. We have an x to the 10th. And we have a y to the 4th. And the denominator all canceled out, so it was just left with a 1 down there. Now, example number 4, we don't have a fraction, so we don't have to worry about that. All we have to do in this example is apply this 2 to both the 7 and the x to the negative 3. So 7 squared is 49. X cubed to the second power, this is a power of a power, which means we have to multiply the exponents. Negative 3 times 2 is negative 6. And then we have an x to the 5th times x to the first. X to the 5th times x to the first is x to the positive 6. Now what we have is x to the negative 6 times x to the positive 6. You are going to add the exponents like we've done in all the other examples. Well, negative 6 plus 6 is 0. So we're left with 49 times x to the 0 power. If you remember, anything to the 0 power is 1. So this leaves us with 49 times 1, which is just 49, is our final answer. Moving on to page 3. Example 1. Now we have to read our instructions very carefully. This says without a denominator, write this expression. So when we have a fraction and we're asked to write it without a denominator, what we're going to do is take each factor in the denominator, move it up to the numerator, and if this is a positive exponent, we change it to a negative. So an a to the positive 4 on the bottom becomes a to the negative 4 on the top. So I'm just going to rewrite this 4a squared b, and then I'm going to move the a to the 4th up to the top and call it a to the negative 4. And then I'm going to use my multiplication rule, which says I'm going to add the exponents. If I have a squared times a to the negative 4th, 2 plus negative 4 is negative 2. So the 4 stays a 4. The a has an exponent of negative 2, and the b just stays a b. So now we've got the result with no denominator. Even though we're not supposed to leave our final result with a negative exponent, our instructions say to write it without a denominator, so that would be the final answer. In example number 2, we're going to do the same thing. We're going to take the denominator, move it up to the numerator, and a to the negative 4th on the bottom becomes a to the positive 4th on the top. So we're left with 4a squared b on the top times a to the positive 4 when it moves up. And then we're going to use the multiplication rule again, add the exponents, and it becomes 4 times a to the 2 plus 4 is 6 times b. And there's our final result. You usually don't get these instructions, but just in case you do, that's how you handle them. In these examples, it says using only positive exponents, which means anytime you have a negative exponent, you're going to move it down. And what I would encourage you to do is try these examples on your own, so you can press the pause button on the video right now and try these examples. And then when you get done trying them, then you can press play again, because I'm going to work them all out for you. Or if you just want to watch me do them, you can do that too. But it would probably be best if you tried them on your own. X to the negative 3 moves downstairs and becomes x to the positive 3. So what we're left with is a 3 on the top, a y to the 3rd on the bottom. He didn't move, but the x to the negative 3 moved downstairs. So there's the first answer. Number 4. You have an x to the negative 3 moving upstairs. You have a z to the negative 6 moving downstairs. So I have 5x squared y, z to the negative 6 moved down, but x to the negative 3 moved up. On the bottom, we have y to the 6 that stayed downstairs because he didn't have a negative exponent, but the z to the negative 6 moved downstairs. And now I'm just going to clean up the numerator by applying the product rule. X to the 2nd times x to the 3rd is x to the 5th. So we have 5x to the 5th on the top times y. And on the bottom, it looks like we have y to the 6 times z to the 6. Oh, but we have a y in the numerator and a y in the denominator as factors, so we can use the quotient rule, subtract exponents, and because y to the 6, the bigger exponent is in the denominator, we're going to cancel out the numerator and subtract those exponents. The y to the 6 becomes y to the 6 minus 1, which is y to the 5th. And so our final answer is on the top we have 5x to the 5th, the y canceled out, and on the bottom we have y to the 5th, z to the 6. Example number 5. We have a few things with negative exponents. A to the negative 2 moves downstairs. When I come across this c to the negative 7 in the numerator and c in the negative 7 to the negative 7 in the denominator, I can move one downstairs and one upstairs if I want to, but it would be way faster if I just recognize they're exactly the same thing. It's like having x over x. C to the negative 7 over c to the negative 7, they just cancel out completely and become a 1. Anything over itself is 1. And then this b to the negative 3rd down in the denominator moved upstairs and became b to the positive 3. Oh, and I have a 4 over 2, which can reduce down to 2 over 1. So what do I have in the numerator? I have a 2. I have a b, this little b right here. And I have this b to the negative 3rd, which moved up and became b to the positive 3rd. In the denominator, the 2 canceled out. The a cubed stayed, because he had the a to the 3rd had a positive exponent. And then this a to the negative 2 moved downstairs and became a to the positive 2. The b to the 3rd moved up and the c's canceled out. So now I'm just going to use the multiplication rule, which says add the exponents. There's an invisible 1 here. So this becomes 2 times b to the 1 plus 3 is 4. All over a to the 3 plus 2 is a to the 5th. One of many ways to do that problem. I'll probably say that 150 more times. Number 6, we have 30 over 15, which reduces over negative 15, which reduces down to 2 over negative 1. We have x to the negative 5th moving downstairs. We have x to the negative 2 moving upstairs. And the y's have positive exponents, so they're not moving at all. So on the top we have a 2. The x to the negative 2nd moved up and became x to the positive 2nd, and the y to the 5th stayed upstairs. In the bottom we're left with a negative 1. The x to the negative 5th moved downstairs and became x to the 5th, and the y cubed stayed. And now we have a chance to use our quotient rule, x to the 2nd over x to the 5th. Because the bigger exponent is in the denominator, you're going to leave the x's in the denominator and use the quotient rule by subtracting exponents. X to the 5th on the bottom, x to the 2nd on the top becomes x to the 3rd on the bottom. And x to the 5th, or y to the 5th over y cubed becomes y to the 2nd over 1. And I think we're ready to write our final answer. Now our whole answer is negative. If there's a negative in the denominator or there's a negative in the numerator, it just means the entire answer is going to be negative. So I'm going to write my negative out in front of the entire fraction. So the fraction has a 2 in the numerator, a y squared in the numerator, and an x to the 3rd in the denominator. And the whole answer is negative. Now what's the mistake that's made here? There was a student that said negative 2 squared times negative 2 to the 3rd. They multiplied negative 2 times negative 2 and got 4 and added the exponents. Well, the mistake is you're supposed to keep the bases. You're not supposed to multiply bases. So the mistake is don't multiply the bases. Negative 2 times negative 2. All right? You keep them. This should be not 4 to the 5th, but it should be equal to negative 2 to the 5th because you keep the bases. Keep the bases in your result. So that becomes negative 2 to the 5th, which is negative 2 times negative 2 times negative 2 times negative 2 times negative 2, 5 times, which turns out to be negative 32, I believe. Though what's the mistake here? X to the 8th over x to the 2nd? Well, the mistake is they divided the exponent. If they thought it was x to the 4th, because 8 over 2 is 4, this person divided exponents. Should have subtracted. Says the quotient rule. So it's not x to the 4th. 8 minus 2 is 6. This should be x to the 6th. And the last example over here, what did this person do? Well, if they think x to the 4th times x, or x to the 4th times x cubed is x to the 12th, they multiplied the exponents when they should have added. So it's not x to the 12th, it's x to the 7th. Silly them. You wouldn't do that. So the next part of this page is we're just going to be evaluating functions for the given values. Without a calculator, we're going to evaluate f of 2 if this is our f of x value. So f of x is equal to 2 to the negative 3 times x to the negative 1, which means we can just add the exponents. X to the negative 3 times x to the negative 1 is x to the negative 4. And f of 2 would be, all you do is replace the x with a 2, so that would be 2 to the negative 4. Well, 2 to the negative 4, if you remember, a negative exponent turns into a fraction, 1 over 2 to the positive 4. And 1 over 2 to the 4th, well, 2 to the 4th is 16, so this is 1 over 16 would be the final answer. So sometimes it's easier to simplify the f of x function itself and then substitute x, or sometimes it's just easier to do the direct substitution right away, like in this next example. So what we have is 2 times 2/3 to the negative x power, but x is equal to 1. So when I substitute x equals 1, I get 2 times 2/3 to the negative 1 plus 4 times 2/3 to the negative 1. Well, we have a fraction with a negative exponent, which says I'm going to flip that fraction upside down and make the exponent positive. So the 2 on the outside stays a 2, 2/3 on the inside flips and becomes 3/2, and the negative 1 turns into a positive 1. And then we have a 4 on the outside, and the 2/3 flips upside down and becomes 3/2, and the negative 1 turns into a positive 1. So we have 2 times 3/2 plus 4 times 3/2. Well, this 2 is really 2 over 1, and this 4 is really 4 over 1. And we can reduce this 2 in the numerator and this 2 in the denominator. 2 over 2 is just 1, and we're left with 3 to the 1st over 1, which is 3. Plus, and now this 4 in the numerator and this 2 in the denominator becomes 2 over 1. And so we're left with 2 times 3, which is 6 over 1 times 1. So 3 plus 6 is 9. So this final answer, f of 1, is equal to 9. Example number 3, we're going to substitute x equals negative 3 in here. So what we have is 3 times x to the negative 2 plus 6 times x to the negative 2. Well, x is negative 3. So we have 3 times negative 3 to the negative 2 plus 6 times negative 3 to the negative 2, but that whole thing is taken up to the third power. Well, we have to simplify inside here. Negative 3 to the negative 2 means that we have a 1 over negative 3 to the positive 2, because a negative exponent moves downstairs. And this next one is 6 times, again, negative 3 to the negative 2 means it's 1 over negative 3 taken to the positive 2. And notice my parentheses, because that's going to be important. And the whole thing is cubed. Negative 3 squared is 9. So I have 3. I'm going to change this 3 to 3 over 1. And I'm going to multiply this by 1 over negative 3 squared is positive 9. And then this 6, I'm going to call this 6 over 1. And then again, 1 over negative 3 squared is 9. And the whole thing is cubed. And now to clean up what's inside parentheses, 3 times 1/9, the 3 changes to a 1, reduces to the 9. Because this is multiplication, you can reduce that down. Now this is a plus sign, so we can't cancel across the plus sign, but we can within this because these are factors. So 6 over 9 becomes 2 over 3. So we have 1 over 1, which is 1, times 1/3, which is 1/3. And then we have 2 over 1 times 1 over 3, which is 2/3. And that whole thing is taken to the third power. 1/3 plus 2/3 equals 3/3. And 3/3 is 1. So what we have left in parentheses is a 1. And 1 to the third, 1 times 1 times 1 is still 1. So the final answer here, f to the negative 3, is equal to 1. One of many ways to do that problem. And then the last example, I'm going to substitute a 2 in for all 3 of those x's. So I have 2 times 2 to the 0 plus 2 to the negative 2 all over 2 to the negative 1. Well, I have some terms here because of this plus sign. So this plus sign means that we can't reduce down like we usually do. If this was times, we could. But 2 times 2 to the 0 is 1, so 2 times 1 is 2. 2 to the negative 2 is 1 over 2 squared, which is 4. And on the bottom, 2 to the negative 1 is 1 over 2 to the first, which is 1 over 2. And then this is a complex fraction, and if you remember how to simplify complex fractions, you're going to multiply by the LCD. The LCD of all 3 of these terms is 4. So you're going to multiply this by 4, multiply this by 4, multiply this by 4. And then that'll be simplified down. 2 times 4 is 8. 1/4 times 4 is 1. And 1/2 times 4, the 4 over 2 reduces to 2 over 1. 1/2 times 4 is equal to 2. And so what we have is 8 plus 1 over 2, which is 9 halves. So f of 2 is 9 halves. And so those are just examples of some f of x problems. That's it for today.